We're gonna have David take it away from here, and David's gonna go over some of the techniques to do some of this stuff with Python.
Thanks, Joe. Hopefully you can hear me okay.
Yeah, sounds good.
Hi, everyone. Hope you don't mind that I'm sitting outdoors today. It's been unbelievably hot here in Massachusetts, so I'm trying to enjoy the cool weather. I am going to go to this page, I guess. So I'm going to share my screen. This is the, I do not have as fancy a module as the other people have. I basically have two things. I have the slides here that I'm just going to go over that have a few things, and then an example that includes a couple of different kinds of unit testing in Python. First of all, let me say thank you very much to Josh and Evan they basically laid out a lot of the things that you have to kind of master and get and consider when you're writing unit tests. I too use unit testing all the time. I think it's a really great way for people for students to get feedback. Basically, you're not telling them like, where is the semicolon missing? You're actually going in to look at their code and giving them meaningful feedback on algorithms, style, and semantics. I'm a high school teacher in Brookline, Massachusetts. I'm gonna, feel free to contact me, just like everybody said, if you have questions on any of this. I've been teaching CS for quite a while, and robotics as well. Many people have already mentioned that you can give meaningful feedback to the students depending on how you structure your unit tests. You can also basically get a point value for how many of the tests the students passed to sort of have as a basic grade, and then you can focus on the things that really matter, the semantic and stylistic feedback, and helping them with algorithms and the deeper stuff, the stuff that's a good use of your time. What are we going to do today? Well, we're going to look at two things. We're going to look at two different kinds of unit testings in Python, Doctest and the unit test modules. There is another thing called PyTest, and I'm sure it's possible to use in coding rooms, but it is a separate application that you actually run your Python code through, and it does some auto grading. I put a link there. You can look at it. A lot of people like it. I don't use it, but it is something that it's a whole framework that's not built into the Python module itself. I mean, it is not a Python module. It's an app. One of the things about unit testing is, where did you get the test data from, right? Do you want to do something very simple, sort of ad hoc, or do you want to have some huge, meaningful, thousands as, a SQL database with 10,000 rows in it? One thing that somebody mentioned that students would just figure out like what they need to type out to pass the test, and they would just do it. On one of my 10 years ago, a student, I give a Thanksgiving problem every year, which is what day does Thanksgiving occur on? And this student went through and said, if it's 2000, Thanksgiving is on the 27th, and if it's 2001, Thanksgiving is on the 24th, and went through and did that. And I only had 100 test cases. Now that class has 50,000 test cases, and so if they really want to type them all in, great, go for it. But that is something that definitely happens. But you need to have reasonably good test data, and there's a couple different ways to do that. So we're going to generate a solution, and you always have to have a solution for your code, right? For the assignment. I mean, that's pretty much a given. I guess you could give an assignment with no solution, but pretty much everybody has to write a solution, and so therefore you have a good opportunity to write some test data. Here are a bunch of links at the end of the presentation in case you need to follow up on any of this. Okay, so here is a very simple assignment. It's write a function that computes the cube of a number, an integer, and another assignment that computes the square of a number. Okay, so if you run this, in one case, if it's just a module like this, where it just has the functions in it that you're expecting the students to complete, it's very simple and straightforward. Really shouldn't do anything, but I'm going to talk first about this Doctest module down at the bottom. And really, you just have to add these 2 lines of code and you can have some automatic testing. So let's take a look at the model solution. I'm going to go over here to the model solution for main. Now, I almost always include code that is stubbed out so that it's stuff, you know, unless I give them a completely blank page, I usually have a stub that at least compiles so that they don't get compilation errors right off the bat. That's kind of your choice. So in this case, it just returns 0 no matter what. But what I really want to do is return you will now see that what my students know that I can't type. So for cube, I want to return n times n times n, and probably down for here for square, instead of this stub, I want to return n times n. Okay, so this should work. If I just run main, I'll get some sort of an output here. But more to the point, now that I have my test, and I'm running Doctest here, but more to the point is if I run Python here, I can actually do some generate some test code on my own, the kinds of things that I'm interested in having the students do. So let's from main import cube square, and I don't know, what do I want to test? Cube 0 should be 0. Okay, cool. Cube 1 should be 1. Oh, but cube negative numbers are important, so I can type cube -1. That should return -1. Cube 1000 should return 1000 squared, and cube. You can see where I'm going with this, right? You can just, all the different cases you think that are interesting, you can just generate this from within the Python shell. Cool. Well, if I grab this text right here, just this, whatever it was that I typed, copy it, and then I go up here and paste it into the doc string for this function. And there's a little bit of futzing around with indenting. You kind of have to make sure that all of the doc strings, all the test cases are at the same level of indent. They don't actually have to be all indented properly, but they just have to be at the same level. Then if I run this now, hopefully, cool. 12 tests passed and 0 failed. So what happened here was what Doctest does, and it's a very simple way to give feedback to your students, is you type in a bunch of stuff you're interested in having their code pass. And then down here, doctest.testmod just runs the module that it's in and makes sure that when you submit this statement to the Python evaluator, that it actually generates this as its output. So this is I think doc tests are really good for, for simple kinds of things. And I'm just going to format this so it lines up. Okay, so this is a very simple doc test that you can do. What about down here? Does this have the, yeah, does this have the up arrow? No, okay. From main import cube. I might want to do something like cube of n for n in range, I don't know, 1 to the, for n in range 20. I could do something like that, or if I really want to, the nice thing about Python is that I can use list comprehension, or I can do 1 to the n. I mean, I can do 2 to the n here. I can get a lot bigger values. Python really doesn't have a limit to fixed point arithmetic, so I can do this. So again, if I like this, if I want them to do something like this, where it's a list, well, that's cool too. I can just go up here and paste that into here. So for example, hopefully this will run. 13 tests pass. So again, this is something, you know, whatever it is you type, then this is what Doctest will look for. Now, again, once I've developed my model solution, you know, what I usually do is just copy this. I've got some stubs here, so I go back to my template, paste it into here, and I do need to get rid of this solution. So here's squares, here's cubes. And you can see that why is this doing this? You can see that this does this. I've pasted some information in here already. And then if the student runs this in here, you can see that the only 2 tests that passed were that cube of 0 is 0, because it always returns 0. So they have to figure out how to make that work. A couple of things is you'll notice up here that all of the tests are printed out. So the student gets excellent feedback as to, Python tells them, I tried to do this, I expected that, I got that. So for this is great, you know, for simple tests, this is great feedback. And you'll notice there's no print statements here, there's no nothing. You just have to simply format your doc string as you would typing from the Python shell. One downside of this is that obviously the student sees the test, that's good. But if the student, you know, does this or something, I think that's not going to work. They're going to do this and they're going to get, even if they pass, there's some kind of, well, they can, I don't know if that caused that kind of an error or not, but if they screw up the doc string, then it can cause a problem that's totally unrelated to their code. So you have to be careful of that. But this is a very simple way to generate test data and then put it in there. Let me go now to talk about PyUnit, or what used to be called PyUnit. Now it's called Unit Test. And this test.py has a very similar, these structures of these tests are very similar to the ones that you were seeing in JUnit. In fact, there is an XUnit testing framework, which is essentially follows, you know, a test run or a test case. There are test fixtures, there are assertions, and all of these JUnit and unit test, and for a lot of different languages, they follow this XUnit format. So there's, you know, I know it's available for Racket and a bunch of other languages. So let's talk about generating test data. Well, what I do I always add in my model solution a generate file, which will generate the test data. So for example, and this format function here just simply formats it so that it could be compiled by Python or interpreted by Python. The really nice thing about Python is that there is this repr function here. So it actually, Python repr will generate code that is compilable by Python. That's one of the really powerful things about Python. So it makes it really easy to do this kind of test data in a Python. It's a little bit more tricky to do it in Java. But I also teach APCSA and use this in Java as well. So let's see, cubes. I actually want to just steal I'm just going to steal this code from here. Where was it? Okay, so I want to do, for generate, I'm just going to generate cubes like this. And instead of this range, I'm going to use my max exponent. You value up here that I just put in as a constant. That way I can change it if it's too many. If I do, 100 of these, and then I run generate, it's like, whoa, yeah, that's way too many. That's way too much test data here. This is the test data that I'm generating, right? It's going to create a list of tests. So that's too many. Let's just do 20. Okay, so if I generate test.py, there's 20 examples. Oh, wait a minute. I actually need to know what the base was as well as the exponent. Well, again, here's Python to the rescue. This actually, because you can return multiple values from a in a tuple, I'm going to include 1 to the n and cube of 1 to the n in a tuple. Let's see if that works. There we go. So there's a base and an exponent, or the square. So here's 2 squared is not, oh, these are cubes, sorry. 2 cubed is 8, 4 cubed is 64, etc. So here's my test data. And because I don't want to run out of time here, I would do this simply for these other ones as well. I would, for negative cubes, I would just change this so that it makes, it's a negative number. So this should be negative, oops. I'm not going to actually do this one. I don't want to run out of time. But I would do this for negative numbers, positive numbers, and negative squares and positive squares. So again, as everybody said, all this stuff will be available. I'm trying to do this live so that we can see the development process. But let's take a look over here at test.py. So here are some data. These are the positive cubes, the negative cubes, positive squares, negative squares, and they're in pairs. They're in tuples, 2 tuples. One thing that someone mentioned is to not use setup or teardown. I always use setup and teardown. I don't always need teardown because if you're not actually nulling out an object or deleting an object from the globals, then you don't really need this. But in this case, what setup is called every time before every test. So if something screws up the data that you're testing with, then you'll generate a fresh set here. And so these are class variables, cubes and squares and negative squares here. So let's take a look down at test cube. How would we test cube? Well, firstly, oops, oh, sorry. I have a bunch of tests in here, but I always like to print out a banner, and there's a banner function in the bottom here just to let them know which test they're in. Now, Coding Rooms does a really good job of parsing, when you run it in the test framework, it does a really good job of parsing what the tests are and printing out and giving lots of good feedback about which tests are being run. So this is something I normally do in other platforms with Java, for example, but I'm going to test cube here. I always print out a banner. Then what's the next thing you should do? Well, I want to do essentially, I'm sorry, because I'm running out of time, I'm just going to grab this. And I want to go through the values in cubes, the n value and the cube value. And I always have print feedback for the students in addition, just before the assertion. So for me, there are 2 things you really need. You need some sort of feedback to the students for every single test case, because then they can see a pattern. If it passes up to a certain point and then it fails, well, then they can that helps them to debug what they're doing. And you need to do this assertion. So what does the assertion do? Well, the assertion has an expected and an actual. And again, you have to import the cube from the student's module up here. And it has an expected and an actual, and it does that assertion. So let's do, for example, what if it was cube plus 1? We would expect this assertion to fail. So I'm going to run test.py here, and you can see that this is my feedback that I get. These other ones passed, which was awesome. You can see all of this feedback that the student is getting, showing that it's passing, right? But the only one that worked with test cube was this very first one. The minute I went to 2 cubed, it didn't work. Why not? Well, down here at the bottom, it says assertion error. I expected, sorry, what is it? Oh, right. One of these. I'm missing I don't see why I don't have my print here. Anyway, the other thing you can add here is you can add another string just like this, just like you could on the Java, the JUnit. So let's try that one. Run test. There we go. Yeah, except that does not tell you what the N and the two N's were. Oh, there it is right here. Cube of 1 should be 1. Oh, and it's actually 2. So this shows you that I should have had cube of 1 to 1, and I actually got 2 is not equal to 1. So here's where again, you have to teach your students to interpret the assertion errors. But these assertions are just like the ones in JUnit, and you can have an expected, an actual, and then some kind of string output that tells them, that gives them some sort of feedback as to what went wrong. I'm going to quickly go over to here. If you look up on the Python documentation, this is the Doctest module. It's very well documented, and there are a lot of examples here. And this is the unit testing module. I just want to make sure that, oops, sorry. The list of assert methods looks something like this. So you can assert equal, not equal. You can assert true or false. That means you can generate your own Boolean. You can assert is not, is none. There's a bunch of things here. But one of the cool things that happens here is there's also an assert raises. So let me just show you that one here. One of the things about doing feedback system out print kind of unit tests, this one here allows you to test for exceptions, because sometimes you really do want to hand a null to your student's code and have it actually generate a null pointer exception, for example. So this test right here is supposed to test for divide by 0. So in Python, the way you do it is you say, with this assertion, 0 division error, I expect 47 divided by 0 to generate that assertion. And I mean that to generate, yeah, that error. And the thing is, that's actually okay. That is a test that passes if you divide by 0. So for example, I'm going to run this, and you can see test exception right here. There's no feedback for them except for the fact that it just passed. So you can put exception, you can put other feedback in there. I just wanted to show you that unit testing, JUnit and Pi unit testing is somewhat more powerful than, there's a lot more things you can do than just simply matching the output and input and output of the strings. So what about the test bench? Well, we've got nothing in the test bench here. The really cool thing about coding rooms is I've run this test here in my model solution that I'm very happy with. All the tests pass, right? I get all the feedback I want. And down the bottom here, I said ran 5 tests, and all these dots here mean that it all passed. I'm just going to take this whole unit test framework, go over to my test bench, add a test case, which is a unit test. And I'm going to call it test all. And I'm not going to go, you guys had very good descriptions of what the hidden means, what the unit test code means, and whether you give some feedback and all of that. But I'm just simply going to paste this whole thing into here, including this stuff down the bottom, which actually I think coding rooms doesn't even run. But as long as I have my import unit test up here at the top, which was part of the coding rooms, let me just show you the template. You sort of saw that from the Java one, but it's very, why can't I scroll here? It's very simple. It just says import unit test. It has a setup, a tear down, and one unit test here that's just assert true. So this assert true, true will always pass. So I'm just going to go through here and paste this in. If I want to run it from my model solutions, the hope is that it passed. And in fact, here's the feedback. All that feedback is there, right? All I did was paste in, and you'll notice that Coding Rooms gives an even, these two lines right here, the test cube thing, that was inserted by whatever Coding Rooms did to parse it. So that's really kind of cool. This is the doc string for my test. So it says test a cube of positive numbers. That's something that I don't even, do in my test code. So, and then when I get all that way down to the bottom here, it passed. Well, that's pretty great. If I want to, I can add one test at a time as well. So if I add another unit test, say this is test cube. If I want to do it one at a time, I can do that. And I don't even know the best way to do this, but I think if I just go up to the top here, I do the setup. I'm just going to leave the setup alone. And if I just do this test cube here and none of this other stuff, I'm hopeful that this will just work. Oops. So what I did was I just have my setup test data and I just have one test here, which is for cube. So now if I run my model solution, you should see that I obviously skipped something here. What happened? Oh, I deleted the banner function. Oh, sorry. Yeah, the banner was at the
comment that
bottom.
line out and be good.
Yeah. Sorry. Where is it? Here. So if I run this on my model solution, then I passed all the tests, and as you can see, I'm now accumulating 2 out of 2 points. This test here is I just copied one of my tests from my model solution. So I would recommend having a generate function where you generate test data. That allows you now, like say a student hits you with an edge case that you didn't think of, right? It's very easy to go back in there, go to your generate function, generate some extra stuff, paste it. All you have to, in many cases, all you have to do is paste that test data into the top of the setup, and then you're good to go. And then you can just copy each one of the tests one at a time and set the different point values. That's the point values and the hidden, non-hidden, all of that. That's kind of up to you, but it's a very flexible approach to that. And I think that's all I wanted to say. So I have 1 minute for questions.
Awesome. Any questions out there? Feel free to write it in. I thought it was interesting, David, what Tim said also, in you really walking through, running things in the interactive and really checking out the tests before bringing them to the test bench. And I think that's a good strategy to really be able to dig into things and run and check out a lot of your tests and what's going on with them. I often recommend that as a secondary, like debugging step, but probably very useful to do just from the beginning with your tests. And the test bench.
It's one of the strengths of Python is that you do have the interactive shell. That is a really positive thing, and you can use it to your best advantage. And you also have the ability, I end up doing a lot of parallel lists in Java, where the inputs are in one list and the outputs are in another list, or sometimes you have a 2D, like on some of the APCS free response questions, you have to generate 2 2D arrays, which are sort of the input and the output. And at least in Python, when you can generate lists and tuples on the fly and dictionaries and everything for your test data, it's the tests become that much shorter. And so I heartily encourage you to use unit test in Python. It's very easy it's much easier than Java to do.
Yeah, awesome. Excellent.